Welcome to Module 8 of the Works Clearinghouse WWC Group Design Standards Training. You can access all of the resources mentioned in this module through the WWC's website, whatworks.ed.gov. This module focuses on the WWC's procedures and standards for two types of group designs in which the participants are observed in multiple time periods. We will describe the additional considerations needed when conducting WWC reviews of group design studies using these types of analyses. Many group design studies in education research use repeated measures analyses, which are defined here as group design studies where individuals are observed in multiple time periods within the design. It is important to note that we are talking about group design studies that use repeated measures analyses, meaning that these designs have an intervention group as well as some type of external comparison group. Sometimes researchers might use the term repeated measures design to refer to a single group of participants who get exposed to multiple levels of an independent variable, but for which there is not an external comparison group. These are not the types of designs we are discussing in this module. Remember that to be eligible for WWC review as a group design, the study design must include some type of external comparison group that does not receive the intervention. For instance, a study might randomly assign units to an intervention and comparison group and collect baseline data. Then, the researchers may collect follow-up data on those participants at multiple time periods, perhaps at 1 month, 3 months, 6 months, and 12 months. In the remainder of this module, we will provide additional guidance on reviewing evidence from two types of group designs with repeated measures analyses. First, analyses of simple gain scores, and second, analyses in which the dependent variable includes data from multiple time points. These types of repeated measures analyses might make sense when researchers are studying an intervention that is of indefinite duration, such as assignment to a charter school. Or these types of repeated measures analyses might make sense when researchers are studying the long-term effects of a short-term intervention, such as a behavioral health intervention designed to instill good habits that can be maintained after the intervention is completed. Before discussing the WWC's procedures and standards for reviewing evidence from repeated measures analyses, we would like to emphasize that the guidance discussed in this module does not apply to scenarios where pre-intervention measures of the outcome are included as covariates in the analytical model, nor to studies using single-case experimental designs. And, regardless of the approach researchers use to analyze any repeated measures, the WWC still requires that the analysis used an acceptable adjustment method based on the information in the study. The WWC does consider analyses of simple gain scores, difference-in-difference adjustments, and fixed effects at the level of the unit of assignment to be acceptable methods for statistical adjustment, but only when there is evidence that the baseline and outcome measures are measured on the same scale, which was discussed in the compositional change module in this training series. WWC reviewers may encounter studies where the researchers report impact analyses where the dependent variable in their analyses include data from all time points in the repeated measures design. Remember that in order for a study to be eligible for review as a group design study, the repeated measures analysis must measure the effect of the intervention by comparing exclusive intervention and comparison groups. So, in this module, we are discussing group design studies using repeated measure analyses comparing exclusive intervention and comparison groups, meaning that a participant can belong to only a single group at each point in time. This means that analyses where the same participant is analyzed as a member of both the intervention and comparison groups at different times, such as in a crossover design, are not eligible for WWC review unless separate intervention and comparison groups are used for group contrasts at each time period after baseline. In other words, the WWC must be able to extract information that is relevant to an intervention impact at a specific point in time. Additionally, in order to be eligible to meet WWC standards, a repeated measures analysis must adequately account for the time periods associated with the intervention and pre-intervention conditions. A study that fails to account for differences across time periods risks producing biased intervention effects if a change in policy or environment unrelated to the intervention is correlated with the outcome in some time periods but not in others. Finally, quasi-experimental designs, randomized controlled trials with a high risk of bias due to compositional change, and compromised randomized controlled trials that pool impact estimates across time periods are ineligible for WWC review. However, if authors additionally report separate impact estimates for each post-intervention time point, the WWC will review those findings, as we will discuss in this module. Let us consider an example to illustrate the types of samples in a repeated measures analysis that would be eligible or ineligible for review under the group design standards. Imagine a study of an intervention that is provided to students in Group A during time period 1, and then the same intervention is provided to students in Group B during time period 2. Students in Groups A and B receive the comparison condition when not receiving the intervention. This type of design is often referred to as a crossover design or switching replications design. If the study authors examined the impact of the intervention separately in each period by comparing students who did not receive the intervention in that period with the distinct group of students who did receive the intervention, then this study would be eligible for review as a group design study, and its findings would have the opportunity to meet WWC standards. However, if the study authors examined the impact of the intervention separately for each group of students by estimating differences between comparison period outcomes and intervention period outcomes within each group, then the study would fail to meet standards in both samples, because the time period would be confounded with intervention status in each group of students, effectively making it a series of two within-group designs. When the analysis of such a study does not provide an impact estimate comparing exclusive intervention and comparison groups from each time period, the WWC will consider the study ineligible for review. A common type of repeated measures analysis used in group design studies is a difference in differences analysis. This type of analysis can be used when participants are assigned to conditions, then are observed once before the intervention is implemented, and then are observed once after the start of the intervention. In the simplest form of this analysis, researchers calculate the difference in outcomes between conditions both before and after the start of the intervention, and then the difference in those differences represents the effect of the intervention. It can also be estimated in a regression model, including additional covariates of interest. Such an impact estimation model will typically include an indicator for condition assignment, Tx here, as well as an indicator for the time period associated with the intervention, and then an interaction term between the condition assignment indicator and time period indicator. The coefficient on the interaction term, or the B3 coefficient shown in this example, provides the difference in differences estimate of the impact of the intervention. The p-value of this estimate is used to assess the statistical significance of the impact. Another acceptable analytic approach for difference in differences analyses is a repeated measures analysis of variance with one between group factor distinguishing the intervention and comparison groups, and at least one within groups factor distinguishing time period. Again, as long as the model contains an interaction of these two factors. If a study only reports the coefficient on the intervention indicator and does not include the interaction term, this will result in a biased estimate of the effect of the intervention, because it measures the average difference in the outcome between the intervention and comparison groups across both the pre-intervention and post-intervention periods. This type of analysis would not provide a credible estimate of the effectiveness of the intervention. If the study authors do not provide the WWC with findings from a credible analysis, then the study finding will be rated does not meet WWC standards. Findings from difference in differences analyses are eligible to meet WWC group design standards if they meet two requirements. First, the impact estimation model used to estimate intervention effects must include the intervention indicator, time period indicator, and interaction terms shown on the previous slides. The inclusion of these terms in the model is required in order for the study to be eligible to meet standards, since the WWC requires these types of analyses to accurately account for the time periods associated with the intervention and pre-intervention conditions. This requirement is typically satisfied by an ordinary least squares analysis that includes the intervention, time period, and interaction indicators as independent variables. And second, in order for this type of repeated measures analysis to be eligible to meet WWC group design standards, the outcome variable must be measured on the same scale at both time periods in the design. Another common type of repeated measures analysis that WWC reviewers may encounter are comparative interrupted time series. In these types of analyses, units are assigned to conditions and observed at several points in time. As a generalization of the difference in differences approach, these types of analyses are also required to include an indicator for the time period associated with the intervention, as well as an interaction term for assignment to the intervention in the post-intervention period. Some researchers conducting comparative interrupted time series analyses also may include additional terms in their impact estimation model in order to adjust for the correlation between time and outcomes, such as linear trends, nonlinear trends, or fixed effects corresponding to each observation time point. And these additional terms in the impact estimation model are acceptable. And although these comparative interrupted time series analyses can incorporate observations at several points in time, remember that a WWC will calculate effect sizes for intervention effects at a single point in time. So, the study needs to estimate impacts separately for each post-intervention time point. Finally, the outcomes must be on the same scale, and this is frequently accomplished via standardization when the measures vary across time. Another common type of repeated measures analysis that WWC reviewers may encounter are growth curve models. In these types of analyses, units are assigned to conditions and observed at several points in time. Again, in order for these analyses to meet WWC group design standards, these types of analyses must include in their impact estimation model indicators for each intervention period, as well as interaction terms for assignment to the intervention group and the time period associated with the intervention. Finally, another common type of repeated measures analysis that WWC reviewers may encounter are analyses of simple gain scores. This type of analysis can be used when participants are observed once before the intervention is implemented and then observed again after the start of the intervention. Gain scores can be calculated by subtracting each participant's pre-test value from the post-test value on the measure of interest. Researchers then may use the resulting difference as the dependent variable in an impact analysis, such as the outcome variable in a regression model used to estimate intervention impacts. The analyses of simple gain scores are eligible to meet WWC standards. However, to be reported by the WWC, effect sizes from gain score analyses must be based on standard deviations of the outcome measure collected at the follow-up time point without adjustment for the baseline measure. Sometimes, study authors may not be clear about whether the standard deviations reported in the gain score analysis are post-test standard deviations or are instead standard deviations of the gain score. And when this is not specified by the study authors, often those standard deviations are for gain scores, not post-test scores. Now, the WWC will convert gain score standard deviations to unadjusted standard deviations if the study authors reported the baseline outcome correlation. And the WWC will request from authors the unadjusted standard deviations of the post-test if they cannot be computed, but are required for the WWC to compute an effect size. Finally, if the WWC cannot calculate an effect size for an outcome based on acceptable standard deviations, then the finding cannot be used to assign an intervention effectiveness rating to the intervention in that outcome domain. But the finding can still meet WWC standards. Those interested in the technical details of these conversions and calculations should see Appendix E in the handbook. Remember that the WWC assesses compositional change, or attrition, in RCTs. So how does the WWC assess attrition in RCTs that use these kinds of repeated measures analyses, where impact estimates are available at multiple follow-up points after the start of the intervention? In these scenarios, the WWC reviews impact findings separately at each point in time included in the analyses in order to assess attrition from the time of assignment to condition. Each impact estimate, or an average of impacts across time periods, is eligible to be rated meets WWC standards without reservations if all groups were formed in an RCT with a low risk of bias due to compositional change. Otherwise, it is eligible to be rated meets WWC standards with reservations. Remember that the WWC also assesses baseline equivalence for all QEDs, RCTs with a high or unknown risk of bias due to compositional change, or compromised RCTs. So how does the WWC assess baseline equivalence in these types of designs when they use repeated measures analyses and report baseline information for more than one pre-intervention period? In this scenario, if study authors observed more than one pre-intervention period, the WWC requires that the authors satisfy the baseline equivalence standard in the pre-intervention period closest to the start of the intervention. However, if the study is a QED with crossover, such as the example discussed in slide 6, then the average impact is eligible to be rated meets WWC standards with reservations only if the baseline equivalence standard is satisfied separately for all time points that contribute to the analysis. In the example, although the two groups may have been equivalent at the start of period 1, exposure to the intervention for subjects in group A during period 1 might lead to differences in the groups at the start of period 2. Alternatively, if participants were randomly assigned to conditions in period 1, then the WWC will review the period 1 finding as an RCT, while the WWC will review the period 2 impact estimate as a QED that must satisfy the baseline equivalence standard because participants in Group A were exposed to the intervention.
Time for your first knowledge check in this module. Researchers used a crossover design to examine the effects of a new student advising service for incoming university students. The researchers randomized students at 4 campuses into 2 groups, with 2 campuses per condition in each group. Students in Group 1 received the new student advising service in fall 2020, and Group 2 continued with their typical advising service. In spring 2021, students in Group 1 returned to the typical advising service, and the Group 2 students received the new advising service. The researchers gathered official records for students' GPAs at the beginning of fall 2020, the end of fall 2020, and the end of spring 2021. The authors report on 4 analyses of intervention effectiveness. First, a difference in differences analysis comparing Group 1's GPA growth from fall 2020 to spring 2021, and then the same analysis for Group 2. Next, they reported on a difference in differences analysis comparing Group 1's GPA growth to Group 2's GPA in fall 2020, and a similar analysis in spring 2021. Which of the following is true? A. All 4 analyses are findings potentially eligible to receive a rating of meets WWC standards without reservations. B. This is a randomized controlled trial with compromised random assignment. All 4 findings are potentially eligible to receive a rating of meets WWC standards with reservations if baseline equivalence is demonstrated for that finding. Or C, the first 2 findings would receive a rating of does not meet WWC standards. The third finding is eligible to receive a rating of meets WWC standards without reservations. The fourth finding is eligible to receive a rating of meets WWC standards with reservations if baseline equivalence is demonstrated. You may want to pause the video to think about your answer. The correct answer is C. To be eligible for review as a group design study, a repeated measures analysis must measure the effect of the intervention by comparing exclusive intervention and comparison groups. This means that a participant can belong only to a single group at each point in time. Analyses in which the same participant is analyzed as both a member of the intervention and comparison groups at different times are not eligible for review unless separate intervention and comparison groups are used for group contrasts at each time period after baseline. In this example, the first 2 findings have each participant serving as a member of both the intervention and comparison groups at different times, so those findings do not meet standards. For the third and fourth findings, participants are only represented in either the intervention or comparison group at any given time period. The third finding is a cluster-level randomized trial with low individual-level non-response, low cluster-level attrition, and an analysis that excludes any joiners. It is therefore eligible to receive a rating of meets WWC standards without reservations. However, because the first group was exposed to an intervention in the fall, the 2 groups may no longer be equivalent in the spring. The fourth finding must be reviewed as a quasi-experimental design, and the finding is eligible to receive a rating of meets WWC standards with reservations if baseline equivalence is demonstrated.
Knowledge Check 2. Researchers examined the effects of a new reading instructional technique using a crossover design. The researchers randomized 120 teachers at 6 schools into 2 groups, with 60 teachers in 3 schools in Group 1 and 60 teachers in 3 schools in Group 2. Teachers in Group 1 received training in the new reading instructional technique in fall 2021, and Group 2 continued with business as usual. Researchers collected baseline and follow-up data for both groups using an instrument that measured teacher self-efficacy with a Cronbach's alpha value of 0.75. In spring of 2022, teachers in Group 1 returned to business as usual, and Group 2 teachers received training in the new reading instructional technique. The authors used the same measure of teacher self-efficacy from fall 2021 before and after the spring 2022 intervention for both groups. The analytic sample consisted of data for all 120 teachers at the 4 time points. A difference in difference analysis was conducted to compare Group 1's teaching self-efficacy from fall 2021 to their teaching self-efficacy in spring 2022. What is the highest rating this finding is eligible to receive and why? Your response options are A. Meets WWC standards without reservations because this is a cluster RCT with 0 individual level non-response and cluster level attrition, and the analysis excludes any joiners. B, does not meet WWC standards because each participant serves as a member of both the intervention and comparison groups at different times. C, does not meet WWC standards because the outcome measure does not meet WWC outcome requirements. Or D, the study is not eligible for review and cannot receive a research rating because it used a crossover design. You may want to pause this video to think about your answer. The correct answer is B. While this study is eligible for review as a group design and has intervention contrasts that could potentially meet WWC standards, repeated measures analysis must measure the effect of the intervention by comparing exclusive intervention and comparison groups, meaning that a participant can belong to only a single group at each point in time. In this example, the findings from this difference in difference analysis would not meet standards because the analysis allows any given participant to be a member of both the intervention and comparison groups across the study analysis period. Additionally, there is no reason to believe that the measures do not meet the WWC's outcome requirements, as they meet the WWC's reliability requirements.
This concludes the 8th module in the WWC Group Design Standards training. Let's review what we discussed in this module. We summarized some of the most common types of repeated measures analyses that may be reported in group design studies. Then, we discussed the special considerations that reviewers will make when applying the WWC Group Design Standards to these types of repeated measures analyses. Remember that you can access all of the resources mentioned in this module on the WWC website, whatworks.ed.gov.